You can also graph linear equations, but make sure the linear equation is in the form y equals mx plus b. This is called the y-intercept form, and it's probably the easiest form to use to graph linear equations. The values in the equation do not need to be whole numbers. Often you'll see an equation that looks like this: y equals 1/4 x plus 5, where 1/4 is m and 5 is b. M is called the slope, or sometimes gradient, and slope is defined as the rise over run, or the change in y over the change in x. B is defined as the y-intercept. The y-intercept is the point at which the line crosses the y-axis. X and y are both variables. You can solve for a specific value of x, for example, if you have a y point and know the m and b values. X, however, is never merely one value. Its value changes as you go up or down the line. This is the linear equation, y equals mx plus b. So you plot the b number on the y-axis. The b is always going to be a rational number. Just whatever number b is, find its equivalent on the y-axis and put the number on that spot on the vertical axis. For example, take the equation y equals 1/4 x plus 5. Since the last number is b, we know that b equals 5. Go 5 points up on the y-axis and mark the point. This is where your straight line will pass through the y-axis. This is an example of where the y point is on the graph. We convert m into a fraction. Often the number in front of x is already a fraction, so you won't have to convert it. But if it isn't, convert it by simply placing the value of m over 1. The first number, numerator, is the rise and rise over run. It's how far the line travels up or vertically. The second number, denominator, is the run and rise over run. It's how far the line travels to the side or horizontally. For example, a 4/1 slope travels 4 points up for every 1 point over. A -2/1 slope travels 2 points down for every 1 point over, and a 1/5 slope travels 1 point up for every 5 points over. Start extending the line from b using slope or rise over run. Start at your b value. We know that the equation passes through this point. Extend the line by taking your slope and using its values to get points on the equation. For example, using the illustration, you can see that for every 1 point the line rises up. It travels 4 to the right. That's because the slope of the line is 1/4. You extend the line indefinitely along both sides, continuing to use rise over run to graph the line. Whereas positive value slopes travel upward, negative value slopes travel downward. A slope of -1/4, for example, would travel down 1 point for every 4 points it travels to the right. Here you can see where the points are on the line according to the equation. And here is the example of the final line. Use a ruler and being sure to use the slope m as the guide. You extend the line indefinitely and you're done graphing your linear equation.